Good morning. Today we're going to start talking about section 6.5, chapter 6, section 5, entitled Multiplying or Multiplication of Polynomials. I'll just call it Multiplying Polys, Multiplying Polynomials. Let's jump right in. Keep a workshop type motif here. Work out lots of examples. Example 1. A in our text is on page 379, and we are asked to multiply 7x cubed, a monomial, times 6x to the fifth. All right. Well, of course, that's a 5 there. Let me clean that up. 6x to the fifth. All right. Of course, we know multiplication is commutative and associative, meaning all these factors are being multiplied and we can arrange them in any way we like. I would probably multiply the numbers, the coefficients first. 7 times 6 is 42. And x cubed times x to the fifth, well, we'll crunch those powers of x together, and then I'll get x to the eighth. Final answer, 42 x to the eighth. Example B, similar. Another monomial times monomial example. One's got a negative coefficient, though. Don't let it throw you. 4b squared times minus 9b to the seventh. Again, let's multiply the coefficients first. 4 times minus 9 is negative 36. And again, the powers of b we can crunch together. B squared times b to the seventh is b to the ninth. So final answer, minus 36 b to the ninth power. Now let's jump right into example 2. Similar, of course. Example 2 again on page 379. This one's a little nastier. We've got, well, it's still monomial times monomial. Let me write some instructions down here. Multiply and simplify. But both of these monomials have two variables. 5x squared y times 8x to the fifth y to the fourth. Again, we'll use our laws of arithmetic, commutative and associative law of multiplication, along with our rules for exponents to grind out a simplified answer here. Let's multiply the coefficients. 8 times 5 is 40. Powers of x, x squared times x to the fifth is x to the seventh power, and y times y to the fourth. Don't forget about the invisible exponent here. Y is just y to the first power. So y to the first times y to the fourth. We add the exponents, y to the fifth. Final answer, 40 x to the seventh, y to the fifth. All right, let's get a fresh screen here. All right, let's look at example 3. Nastier still as we climb up the ladder. Again, example 3 on page 379. Two parts to this one as well. Example 3a, we've got, well, this monomial has 3 variables. So we've got 6x, y squared, z to the fifth power, that is a monomial, times minus 3, x to the fourth, y to the seventh, y to the seventh, to the seventh times z. All right, all these factors are being multiplied, so I can multiply them in any order I like. Let's crunch the numbers together. 6 times minus 3 is negative 18. I've got 1 factor of x times 4 factors of x. That'll give me 5 factors of x. Y squared times y to the seventh. I'll add the exponents, keep the same base, and add the exponents, y to the ninth. And z to the fifth times z to the first power is z to the sixth power. Final answer, minus 18 times x to the fifth, y to the ninth, z to the sixth. All right, all of the above examples have been a monomial times monomial. That's above. Now I want to talk about a binomial, or let's discuss it, a monomial times a binomial. And that we're going to do down here with a couple of examples here. Example 4 in our text on page 380 states we need to multiply 3x times 2x squared plus 4. All right, I'm multiplying a monomial times a binomial. Monomial times a binomial. And to do that, we'll apply our distributive law. This is an implied product here, so I can just carry that factor of 3x through and multiply each factor of that binomial times 3x, and then simplify the result if necessary. All right, here we go. 3x times 3x times 2x squared gives me 6x cubed. Don't forget x is x to the first power. Plus 3x times 4 is 12x. All right? Not much of that one. Final answer, 6x cubed plus 12x. All right, example 5 plays the same game. Also on page 380. But here you're multiplying a monomial times a trinomial. But the idea is the same. Let me write down the problem. Minus 3n times 4n squared minus 2n minus 1. Again, here we've got a monomial times a trinomial. And to crunch that out, we'll have to apply our distributive law really over 3 factors in that trinomial. Okay? Here we go. All right, minus 3n times 4n squared, that's going to be negative 12n cubed. Don't forget, n is n to the first power. Then, minus 3n times minus 2n is going to give me plus 6n squared. Negative times a negative is a positive, and n times n is n squared. Finally, minus 3n times negative 1 is, of course, just plus 3n. Right? Final answer, negative 12n cubed plus 6n squared plus 3n. All right, I'm going to skip example 6. Let's go on to example 7 in the text. And this is on page 380. Again, we've got another monomial times trinomial. But this trinomial has 2 variables in it. And that can happen. Again, I'll just apply my distributive law, successively multiply 2x by each term in this trinomial and combine the result. 2x times 3x squared y. Well, let's see. 2 times 3 is 6. Multiplying the coefficients. X times x squared is x cubed. Multiplying the powers of x. And no other powers of y out here, so you just carry a y through in that first slot. Minus 2 times 6 is 12. I get a negative 12 coefficient in the second slot. X times x is x squared, and another single factor of y in that second term. By the way, that's a 2 there. Clear it up. Okay. Next, plus, well, 2x times 5 is 10x. Final answer, 6x cubed y minus 12x squared y plus 10x. All right, example 8 is an interesting example. Again, example 8 on page 380. We are asked again to multiply some polynomials. But things are a little bit different here. Let me write down the question. 3x cubed minus 2xy plus 3 times 4x. Well, you can multiply left to right or right to left, however you prefer. I would probably look at this 4x and say, well, I've got a multiplication here, and I'm going to distribute that factor of 4x across all three terms in that trinomial expression. All right? 4x times 4x, try it again, times 3x cubed is going to be 12x to the fourth power. Next slot, minus 2xy times 4x, that'll be a negative 8x squared y, plus 4x times 3 is, of course, 12x. Final answer, 12x to the fourth power minus 8x squared y plus 12, not 1x, 12x. Oops. 12x. Okay. All right, next thing I want to talk about is multiplying binomials. All right, if you're multiplying a polynomial by a monomial, well, really all you do is apply your distributive law and, of course, your rules for exponents. When you're multiplying a binomial, or two binomials, well, it's things we've done before, I'm sure. Let's look at example 9 on page 381. We are asked to multiply 3x plus 2 times x minus 5. Well, of course, you recall the FOIL method from your high school days. You multiply your first product, then you multiply your outer product, then you multiply your inner product, and finally multiply the last product and add the results and combine and simplify as needed. All right, so let me go ahead and let me rewrite this. Well, let's take 3x plus 2 times x minus 5. All right, the first product is 3x squared. The outer product is minus 15x. The inner product is plus 2x. And the last product is minus 10. All right, now often, but not always, but often the inner and outer product are like terms and of course can be combined. So combining those like terms, minus 15x plus 2x is minus 13x. Final answer, 3x squared minus 13x minus 10. All right, let's do some more of these examples. Multiplying two binomials. This one's example 10 on page 381. Again, multiply x minus 4 times y plus 3. That's a y there. Right? X minus 4 times y plus 3. Again, we'll work it out with our first, outers, inners, lasts. First, outers, inners, lasts. Right? First product is xy. Right? Outer product is plus 3x. Inner product is minus 4y. And the last product is minus 12. All right, notice none of these are like terms. None of these can be combined. So this is our final answer. It's a 4-term polynomial. Let's try a couple more of these. We get a fresh screen. And scroll up. And let's look at example 11. On page 382, 2x minus 3 times x plus 4. All right, again, first, outers, inners, last. Firsts, outers, inners, lasts, and add up those products. First product is 2x squared. Outer product is plus 8x. Inner product is minus 3x. And the last product is minus 12. Of course, here the inner and outer products are like terms. So I'll write a final answer, 2x squared plus 5x minus 12. Final answer. All right. Some of these examples get a little more exotic. Maybe we won't do all of them. Let's look at a couple of them. Example 12. Again on page 382. Talks about, well, 4 minus 2x. Now, not all these polynomials that they're giving you have to be in standard form. We can still multiply them. Notice these are left to right increasing degree rather than decreasing degree. That's okay. We should still be able to handle it. First product is 24. 4 times 6 is 24, right? Outer product is minus 20x. Inner product is going to be minus 12x. And the last product is going to be positive 10x squared. All right. All right, first, outers, inners, last. All right, let's combine like terms as we can. All right, these inner and outer products are like terms, so I can combine those. 24 minus 32x plus 10x squared. And that's a fine answer. They don't necessarily have to be in standard form unless specified. But I'll go ahead and use my commutative law addition to arrange these terms in decreasing degree, thus giving the answer in standard form. 10x squared minus 32x plus 24. All right, we're going to do two more, and we'll call it a day. Let's see, this is example 13 on page 383, right at the top. We multiply 4p plus 5 times 4p minus 5. All right, 4p plus 5 and 4p minus 5 are what we call conjugate binomials. They're not opposites, but the sign in between is different. Okay? And something very interesting happens in that case. All right, let's go to the first product. Will give me 16p squared. The outer product is minus 20p. The inner product is plus 20p, and the last product is minus 25. Notice when you multiply conjugate binomials, the outer products and the inner products will cancel each other out because they're the same in magnitude but opposite in sign. Right? This is often called a difference of squares pattern for obvious reasons. if you multiply conjugate binomials, you will always end up with a difference of squares. Notice 16 is a square, p squared, of course, is a square, and 25 is a square. I suppose we could rewrite this as 16p squared minus 5 squared. Difference of squares. Okay, well, that will come back to haunt us a little later. All right, one more. We'll call it a day. We'll look at example 17 in the text. This is on page 385. Multiply 3x plus 4 times 2x plus 5. All right, the book makes a big deal about a table method, and if you want to use it, that's fine. I'm not going to use it. I'm just going to go ahead and attack it with our FOIL method. First product is 6x squared plus the outer product is 15x plus the inner product is 8x plus 8x. You write that in gold. Oh, let me erase that. Plus 8x. And the last product is 20, positive 20. All right, and of course, here in this case, the inner and outer products again are like terms. So I'll combine them. Let's see, 15x plus 8x, that's 23x plus 20. So final answer, 6x squared plus 23x plus 20. All right, we'll call it a day. This concludes section 6.5, multiplication of polynomials.